Hello friends, welcome to my channel Sulba Sutras Academy. My name is Sumit Mishra and today our topic is rational number and their decimal expansion, which is exercise 1.4 of CBSE class 10 maths. Okay, so let's start. So first understand what is rational number. So before moving to further, as I have explained also in the number system as well as in previous exercise, that about rational number. So what is rational number? So a rational number is a number which can be represented as a ratio of p by q, where p is an integer, so z is actually integer, q is an integer and q not equals to 0. So we know these things from our previous videos. Okay. Now here we are going to learn about the decimal expansion also. So before moving to further, let's understand terminating, non-terminating. What is terminating? What is terminating decimal and what is non-terminating decimal? So there are some ratio which terminates when you divide numerator by denominator, so you will get some data in the point form, in the decimal form. So that will be terminating after a certain digit. After a certain digit. Take example. 1 by 2. So 1 by 2, if you are dividing, so since 0, 1.0 to 5 ja to 10 ja. So you can see this. We didn't get anything over here. It got totally divided. It's terminated after one digit of points. After point there is one digit only. No further division. We are getting 0.5. Similarly, take example of 3 by 5. Okay. So 3 by 5, if you are dividing 3 with 5, so of course 0, 0, sorry, 3, so comes 0.630. So we have got 0.6. So you can see this in both these examples, it terminated after, if you are dividing, it got terminated after a digit. So this type of fractions are called terminating fractions. Okay. And the funda is how you will distinguish, how you will know that a given fraction is terminating or not. This is very important. How you will understand, if some fraction has been given to you, how you will able to understand that it's a terminating fraction. So let's understand, if the denominator, if p by q, if q is of the form 2 to the power n into 5 to the power m, where n and m can be anything greater than equals to 0. Okay. It can be same value also. N and m can have same value also and different value also. So n can be from 0 to infinity and m can be from 0 to infinity. Okay. If you are able to represent the denominator, understand, I am not talking about numerator, I am not talking about p, I am talking only about q. So if you are able to convert q of the form 2 to the power n into 5 to the power m, that n and m is greater than equals to 0, then the given fraction will be a terminating fraction. Okay. So let's take any example like 1 by 125. Okay, or any number like 3 by 125. I can write anything. So this will be 1 by 125 is 5 cube. See over here. In this case, see, now match it with 2 to the power n into 5 to the power m. So what you are getting? N equals to 0. If this equals to 5 cube, then of course n equals to 0 and m equals to 3. As we know that anything to the power 0 is 1. You see over here 2 to the power 0 into 5 cube. So 2 to the power 0 is 1. So 1 into 5 cube. So we got 5 cube. You see over there, here I have put n as 0 and m as 3. So if you are putting this value, you are getting 5 cube. So of course over here in this expression 1 by 5 cube, n is 0. That is, the power for 2 is 0 and the power for 5, that is m, is 3. Okay. So this satisfies this form. You see, n is greater than equals to 0. Of course, this satisfied. M is greater than equals to 0. This also satisfied. And it has only factor of 2 and 5. There is no other factor. Correct? You can see this. We have only factor of 5 over here. So, it's a terminating. I don't need to divide it. I can simply tell yes, it's a terminating. Now, take an example of another. Suppose 2 to the power 2 by suppose 3 into 5, so suppose 2 by 105 is there. Okay, now 105 can be written as, if you will do LCM for 105, then 3, 35, 5, 7, 7, 1. So 2 by 3 into 5 into 7. Correct? So I did the LCM for 105. Whatever factors are there, that I have written over here. Now see over here. Of course, n is 0 over here. Power for 2 is 0. No issue. And m is 1 over here. That is correct. But we have extra factor 3 and 7. I told you, it should not be other than 2 and 5. Any fraction where it is other than the power for 2 and 5. Here it has a factor of 3 and 7, whose power is 1, 1 only, which is extra, which is not required for a terminating. It will be terminating only when there is a power for 2 and 5 only. But here we are seeing we have power of 3 and 7 also. Correct? We have 3 to the power 1 into 7 to the power 1. So we have other factors than 2 and 5. Hence, this 2 by 105 is non-terminating. So the non-terminating, so I have distinguished terminating and non-terminating. So non-terminating fraction are fraction. So non-terminating are a fraction where the denominator is not of the form 2 to the power n into 5 to the power m. If it is not of this form, if it is have other factors also, then it will be non-terminating fraction. It's very simple, terminating and non-terminating. I have given you example for both terminating and non-terminating. Okay? Yeah. Now, instead of a fraction, people we can get some point numbers also, some real numbers also we can get. So how we can convert? How we can convert a real number to a fraction? Take an example of 0.3 375. Take an example for this. Okay, how we can convert this as a fraction? This is very important thing. So if you will look at this, first write like this. In the top numerator, it will be 375 as it is. Now we have 0.375, correct? Write 0.375 in the numerator. Okay. Now understand. If we will remove this point, so for point, number 1 will come in the denominator. What I told? If you are removing point, number 1 will come in the denominator. Okay? And after point, how many digits are there? So here we have 3 digits. Correct? So we have 3 digits after point. In 0.375, you can see over here there are 3 digits. So when you are removing the point, so for point 1 came. But since there are 3 digits after point, for that there will be 30 in the down. Okay? What I told? The first thing is, if you are removing point, 1 will come, and then how many digits are there after the point? That many 0 will come on that 1 in the denominator. So this 0.375 is equivalent to 375 by thousands. Okay? Now this 0.375 is this fraction. Now this gets converted to 375 into 10 cube. So 375 divided by 2 into 5 whole cube. Correct? 10 I have written as 2 into 5. Okay? So we know that x into y to the power m is x to the power m into y to the power m. That means what I told you is, the formula is x into y to the power m equals to x to the power m into y to the power m. Okay? So we can write these things as 375 divided by 2 cube into 5 cube. Now look over here. We have in the denominator, we have 2 to the power n into 5 to the power m. So here n equals to 3 and m equals to 3. So it's a terminating decimal, of course, because 0.375, that already we took terminating. But from this fraction also, we have determined that it's a terminating decimal. So you understood how to convert a point to a fraction. Okay, this is very important. So for point, 1 will come, and after point, how many digits are there? That many 0 will be put on 1. This is very important thing. Okay, so there is a theorem for you that let x be a rational number whose decimal expansion terminates, then x can be expressed in the form p by q, where p and q are co-prime. Now what is co-prime? Co-prime are the numbers, are pair of numbers which doesn't have any common factor. Okay, there will be no common factor between that pair of numbers. I have explained you this co-prime already in the previous video. Please go through that. If you have any doubt, you can look at that video. Okay, so what it is telling is, if x is a rational number whose decimal expansion terminates. Okay, so we have a rational number x, whose decimal expansion terminates. Okay, so it's a terminating rational number. Okay, whose decimal expansion is terminating. Then x can be represented in the form of p by q. Okay, where p and q are co-prime. okay, where P and Q are co-prime, and the prime factorization of Q, of course, that means Q can be represented in the form of 2 to the power n into 5 to the power n. Correct? This is opposite of what we did in the terminating. While explaining, I told you, right, if we have a given rational number, okay, so it will terminate when it is of the form, the denominator is of the form 2 to the power n into 5 to the power. Similarly, same thing over here is, if x is a rational number, x is a rational number which is terminating, so whose decimal expansion is terminating, okay, then x can be represented in the form of p by q, where p and q are co-prime and q can be represented in the form of 2 to the power n into 5 to the power m, where n and m is non-negative integers. That means it should be greater than equals to 0. Okay, so I have explained you already in the previous for terminating things how to do that. Okay, then opposite is also true, that if x equals to p by q, a rational number, then the prime factorization of the q is of the form 2 to the power n into 5. So both this theorem are opposite. If you are able to convert this denominator to 2 to the power n into 5 to the power m, then it's a terminating decimal. First one was, if it is terminating, if a given rational number is terminating, then it can be represented in the form of p by q. Okay, if x is a rational number which is terminating, I mean whose decimal expansion is terminating, then x can be represented in the form of p by q, where q is of the form 2 to the power n into 5 to the power n. Okay, now opposite is also true. If x equals to p by q, that means it's a rational number such that the prime factorization of the q is of the form 2 to the power n into 5 to the power m, where n and m are non-negative integers, then x has a decimal expansion which terminates. So in the first theorem, we go opposite, where I told x is rational and terminating, then x can be represented in the form of p by q, and p and q are co-prime, and q equals to 2 to the power n into 5 to the power n. Okay, and nm is greater than 0. Opposite is, this is the first theorem. Now second theorem is, if x equals to p by q, okay, and it's a rational number, if x equals to p by q and it's a rational number such that the prime factorization of q, prime factorization of q is of the form 2 to the power n into 5 to the power m, okay, where n and m are greater than, that is n and m are non-negative integers, then x has a decimal expansion which terminates. As simple as that. First theorem we already took that x has a decimal expansion which terminates. Okay, x is a rational number and its decimal expansion is terminating. That was the first one. Okay, if you will see over here, x is rational and its decimal expansion is terminating. Then x can be represented in the form of p by q, where q and the prime factorization of the q is of the form 2 to the power n into 5 to the power n. Correct? So x can be represented like this, and q will, p and q are co-prime, and q equals to 2 to the power n into. Now here opposite is there. we have already told x equals to p by q and rational such that prime factorization of q is of the form 2 to the power n into 5 to the power m, and nm is greater than equal, then x has a decimal expansion which terminates. See this? This we have taken for the and we proved this. Okay, in the second we took this and we are proving that it will be terminating. So this two is opposite of each other. Okay. Okay. Now one more theorem is there. This is almost, yeah. Now non-terminating. One theorem is for non-terminating. So what is that theorem? So that theorem is tell that if x equals to p by q, okay, where p and q are co-primes, where p and q are co-primes, okay, be a rational number, okay, such that prime factorization of q is not in the form of 2 to the power n into 5 to the power m. Okay, of course n m is greater than equals to 0, that is n and m are non-negative integers, then x has a decimal expansion, which is non-terminating. This I have already explained you with example in the beginning only when I was explaining you terminating and non-terminating. So if q is not of the this theorem is as simple as, if q is not of the form 2 to the power n into 5 to the power m, that means the decimal expansion will be non-terminating. Okay. So non-terminating, repeating. So repeating in the sense is if you are taking and recurring also you can. Okay. So what does it mean repeating, recurring? So if you will divide 1 by 3, you can see this. 0, 1, 0.3, 3 ja 9, 1, again 10, 3. You see this? Now this 3 is recurring. You can see this, right? Again 0, again 3. So this 3 is recurring. Okay. So I can write this as 0.3. We write it as bar. If it is recurring, we write bar on the top of 3. That means this 3 is going to repeat again. Okay. It can be on the multiple number, like it happens in some cases, like if suppose 0.232323, like this it will come. So in this case I can write it as 23 bar on the top of 23, so that it will express that 23 is going to repeat and repeat and repeat if you are dividing it further. Okay. So this is all about repeating, terminating, non-terminating, everything I have explained you. Now move on to the chapter. Okay. And we'll do the chapter. Let's then start. So okay. So we are going to do exercise 1.4. Okay. So The first problem is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Okay, so you remember, right? If I am able to write the denominator in the form of 2 to the power n into 5 to the power m, then it will be terminating decimal. And if we are not able to convert in that form, then it will be repeating decimal or non-terminating repeating decimal expansion. Okay. So the first question is 13 divided by 3125. Okay. So 3125, let's do LCM. Okay. 5. Since 5 is over here, I can divide it by 5. So 5 6 are 30, 1 12, 5 2 are 10, 2 25, 5 5 are 25. Again 5 is there, so I can again go with 5. 5 1 are 5, 1, 12, 5 2 are 10, 2, 25, 5 5 are 25. Again 5 is there, so I can divide it by 5 again. So 5 2 are 12, 5 2 are 10, 2, 25, 5 5 are. Now again 5 is there, so I can go with 5. So I'm talking 5 is there, that is at the unit digit. If it is 5, then we can divide it by 5. If it is 0 or 5, okay, if the unit digit is 0 or 5, then we can divide that number by 5. So 5 5 ja 25, 5 1 ja 5. Okay, so how many 5 are there? 1 2 3 4 5. Okay, so I can write this as 13 divided by 5 to the power 5. Clear? Because there are 5 5, so 5 into 5 into 5, and so since 5 5 are there, that can be written in the power form as 5 to the power 5. How many numbers of 5 are there? That will become the power of that. If suppose 3 into 3, some of you might know, some of you might not know. For them I am talking 3 into 3. Then since there are 4 3, 1 2 3 4, so in the power form it will be written as 3 to the power 4. So how many 3's are there? That becomes the power of the number. Okay. So it becomes 13 into 5 to the power 5. Now see the denominator. I don't bother about the numerator. What is important is denominator. Okay. So denominator is the bottom one. Numerator is the top one. Okay. So 5 to the power 5. So 5 to the power 5, you compare it with 5 to the power 5, you compare it with 2 to the power n into 5 to the power n. Okay. Can you see this? Here n is 0, m is 5. Why? Check it. 2 to the power 0 into 5 to the power. I will put in the expression 2 to the power n into 5 to the power m. I will put n as 0 and m as 5. So 2 to the power 0 is 1 into 5 to the. So anything multiply with 1. So anything to the power 0, the thumb rule is anything to the power 0 is 1. Remember that. Okay. So 1 into 5 to the. So any number multiplied with 1 is the same number. So it gave me 5 to the power. So that is why I took n as 0. So don't get confused. N, if nothing is there, that means the power thing is 0. The n is 0 over here. Okay. Since there is no factor of it, 2. Since there is no factor of 2 in the denominator, okay, so n is 0. As simple as that. I had shown you how it is. I put n as 0 and m as 5. So I got 5 to the power 5. See over here in the denominator we have 5 to the power. That's why, understand, for the factor of 2 there is no power, so their power becomes 0. So n is 0. I have proved how. And m is 5. Okay. So of course the denominator is of the form 2 to the power n into 5 to the power m, where n equals to 0 and m equals to 5. Hence, so what is the rule says? N and m should be positive. It can be 0 or more than 0. So we have already got n as 0 and m as 5. That means it satisfied our theorem. So hence, the given fraction is terminating. Okay? Since I were able to represent it of the form 2 to the power n into 5 to the power m, also n and m is greater than equals to 0. So the whole thing gets satisfied. Hence, it's a terminating fraction or terminating rational number, you can say. Okay? So it's a terminating fraction or terminating rational number. So it's terminating. That is the important thing. Okay? Now second one is 17 by 8. So 8, if you are doing LCM, 2, 4 ja, 2, 2 ja, 2, 1 ja. So since there are 3, we can write it as 2 cube. So this whole thing we can write it as 17 by 2 cube. Okay? Now compare this denominator 2 cube with 2 to the power n into 5 to the power n. So what we are getting? N equals to 3, and since there are no power for 5, so we can write m equals to 0. Okay? Now this also satisfied our given things, because the denominator we were able to convert it in the form of 2 to the power n into 5 to the power m, and another thing was n comma m should be greater than equals to 0. So you see this, n is greater than equals satisfied, m equals to 0, this is also satisfied, right? Greater than equals to 0 is there. So for these things satisfied, whatever I have got, this satisfied our condition. Hence, so write the statement as above I wrote. The denominator is of the form 2 to the power. I am not going to write the same line again and again, but you have to, when you are doing the problem, you have to tell the exactly that denominator is of the form 2 to the power n into 5 to the power m, where n equals to 3 and m equals to 0. Hence, this is terminating. Hence, it is terminating. Okay? Now, third one. Third one is 64 by 455. Okay? So, 455, let's do LCM. So if we are doing LCM, since you see this, the unit digit is 5, so it will be divisible by 5. So 5 9 ja 45 and 5 1 ja 5. Now 1 is there. So 1 comes in the table of 3. Okay? 3 7 ja 21. Okay? But if you will divide it to 91 by 3, it will not be divisible. The next thing that comes in my mind having 3 is 13. Of course, it will come in the table for 13. So 13 7 ja 91. 7 1 ja 7. So what I have got? 64 divided by 5 into 13 into 7. Now, so here denominator is not in the form of 2 to the power n into 5 to the power. Why I told it is not in the form? Because you see over here there are 13 and 7. So it should only have a factor for 2 and 5, 2 to the power n into 5 to. So any power of 2 into multiplied with any power of 5. There should be no other numbers should be there, no other power should be there. So you can see over here we have other than 2 and 5. Since 2 is not there, so that is fine. 5 is there, so 1 is satisfied, this is there, but there is 2 extra thing 13 and 7 that should not be there. If it was only 5 then fine, but since we have 2 extra thing 13 and 7, hence it is not of the form 2 to the power n into 5 to the power m. Hence the decimal expansion will be non-terminating. As simple as that. If it is not of the form 2 to the power n into 5 to the power m, then it will be non-terminating and repeating. Non-terminating, repeating. Okay. So it will repeat after a certain interval of time. Okay. So fourth one, 15 by 1600. 15 by 1600. So let's do the LCM. So 0 is there. You can see first 16 is divisible by 2. So let's go with 800 again divisible by 2, 400 again divisible by 2, 200 again divisible by 2, 100 again divisible by 2, 50 again divisible by 2, 25. Now 5 is there, so it will go with 5, 5 5 is 25, 5 1. So you can see how many 2's are there, 1 2 3 4 5 6. So there are 6 2. So it will be written as 2 to the power 6. How many 5 are there? 1, 2. So 5 square. 2 to the power 6 into 5 square. Since there are 6 2 and 2 5, so we will write it as 2 to the power 6. How many number of 6 are there? 6. So it will be how many number of 2 are there? Sorry. How many number of 2 are there? It's 6. So 2 to the power 6. How many number of 5 are there? So 5 to the power 2. Okay, so it will be written as 15 divided by 2 to the power 6 into 5 square. Okay, now compare this denominator. So compare the denominator with 2 to the power n into 5 to the power m. So what we are getting? N equals to 6, m equals to 2, and also n and m is greater than equals to 0. This condition also, this is also important thing. It should not be negative. So whatever we have got, that satisfied this. N is greater than equals to 0 and m is greater than. This means if I am doing n comma m greater than, that means n should be greater than equals to 0, m should be greater than equals to 0. So I have written together, you can write it separately also. Okay, so here n equals 6 and m equals. So hence we can say, since the denominator is of the form 2 to the power n into 5 to the power m, where n equals to 6 and m equals to 2. Hence the decimal expansion of 15 by 1600 is terminating. As simple as that. Since we were able to convert this of the form 2 to the power n into m 5 to the power m, and also n and m is greater than equals to 0, hence it is terminating. Okay, let's move on to the next problem. So fifth one is 29 divided by 343. Let's do 343. So its last digit is 3. So which table 3 is coming? 2 table 3 comes? No. 3 tables 3 comes? Check it. If, other than 3, the last digit should be 3. 3 into 1 is coming, but that is not true. In the end, whether it's coming. It should be 2 digit or more than 2 digits. So if we'll see that, then there is no digit where 3 will come. Then go for 4, no. 5, no. 6, no. 7, yes. How? 7 1 is 7, 14, 7 3 is 21, 7 4 is 28, 7 5 is 35, 7 6 is 42, 7 7 is 49, 7 8 is 56, 7 9 is 63. So yes, it's coming in the 7 table. Now let's go with 7, trial and error. So 7 34 is there. So 7 4 is 28, 6 63, 7 9 is 63. Yes, it's coming properly. So 7 4 is 28, 6 63, 7 9 is 63. Again, it's 49 is coming in the 7 table. 7 7 is 49. Finally 7. 1 is 7. So this will be written, since 3 times 7 is there, so this can be written as 7 cube. So 29 by 7 cube. Now compare this with 2 to the power n into 5 to the power m. Is it of the form 2 to the power n into 5 to the power m? No. Okay. As the denominator is not of the form 2 to the power n into 5 to the power m, hence the decimal expansion of 29 by 343 is non-terminating repeating. Clear? So it is non-terminating and repeating. Okay. Let's move on. What is the next problem? Sixth one. So sixth one is 23 divided by 2 cube into 5 square. So here we don't need to do LCM, he has already given it. Now compare this denominator with 2 to the power n into 5 to the power. Write it down. Compare the denominator 2 cube into 5 square with 2 to the power n into 5 to the power m. We get n equals to 3 and m equals to 2. Of course, the condition and m should be greater than 0 is also satisfied. Okay, so both this thing got satisfied for terminating. Hence, the given 23 divided by 2 cube into 5 square is terminating. As simple as that. Okay, since we were able to represent in the form of 2 to the power n into 5 to the power m, and also nm is greater than 0, hence it is terminating. Seventh one. So seventh one is 129 divided by 2 square into 5 to the power 7 into 7 to the power 5. Again, here we don't need to do LCM. Now compare the denominator with 2 to the power n into 5 to the power m. So what we are seeing? We have a factor for 7 also, correct? Of course 2 and 5 is there, but we have an extra factor for of 7 also. Okay, there should be no other factor other than 2 and 5, but we are seeing here we have a factor for 7 also, hence it is non-terminating repeating. Non-terminating repeating. Okay, next, eighth one is 6 by 15. Okay, so 6 by 15. So here if you will see okay, if you will see here, the 6 by 15 is not co-prime. Okay, is not co-prime. So we have to convert this to prime thing. So 2 into 3, we can write 6, 2, 3 ja, 3, 1 ja. So 6 I wrote 2 into 3, and 15 I wrote 3, 5 ja, 5, 1 ja. Okay, so actually in 15 by 1600 also you can do it like this. I didn't do this, but yeah, even after doing, if you will see over here, 15 is 3 into 5 and 1600 is 2 to the power 6 into 5 square, of course. So it will give me 5 if you are removing 1, then also 3 by 2 to the power 6 into 5. So 1 power will go, 5 to the power 2 minus 1, so 1 power will go. Because 5 square is 25, so 5 5 is 25. So I remain with 2 to the power 6 into 5. So in this case also, if you will see, still, I mean, even after cutting the things, we are getting n as 6 and m as, instead of 2, I get 1. Okay, so still it is terminating. But if you look at over here, 3 into 5, here if we are not cutting it, then it will be non-terminating, as there are factor for 3. But since we have already, I mean, it's been told it should be co-prime, so first we have to convert it to co-prime. I mean, there should not be common factor of in the numerator and denominator. So cut the common factor and then check. So 3 3 cancel, we are getting 2 by 5. Okay, now if you are comparing the denominator with, no further division can happen. So if you are comparing the below one with 2 to the power n into 5 to the power m, what you are getting? N equals to 0. Since there is no factor of 2, so n equals to 0 and m equals to 1. So n equals to 0 and m equals, so which satisfies n greater than is, n should be greater than 0 and m should be greater than equals to 0. So this both is satisfied. Okay, hence 6 by 15 is terminated. Okay, this is very important. So first we have to convert it to co-prime. I have done, I didn't cut it in problem 15 by 1600. There also you can cut 1 5 and then do the normal operation, still you will get it as terminating. Here also in this problem, first I need to make the numerator and denominator as a co-prime, and we can bring it to the lowest possible values after cutting and then apply the form 2 to the power n into 5 to the power n. That is what being told in the theorem also, that p and q should be co-prime. Okay, now let's move on. So the next problem is, ninth one is 35 by 50. 35 by 50. Here also 35 if you are doing, 5 7s are 35, 7 1. So 5 into 7 divided by 50 if you are doing, then 2, 25, 5, 5, okay, and then 5, 1. You are getting 2 into 5 into 5. So even when you are cutting it, we are getting 7 divided by 2 into 5. Now you write it in the form of 2 to the power n into 5 to the power. Compare this. So what we are getting here, what is, if no power is there, that means 1 is there. 2 is nothing but 2 to the power 1. 5 is nothing but 5 to the power 1. Okay, anything to the power 1 is the same number. Okay, so what we are getting, n equals to 1 and m equals to 1. So which proves that n is greater than equals to, this is also true. So this condition is satisfied. M should be greater than equals to 0. This is also true. Okay, because n is 1 and m is 1. Here it is telling m should be greater than 0. But we have 1. So 1 is greater than equals to 0, which is true. Similarly, n is 1 and n should be greater than 0. If you are putting 1, 1 is greater than 0. Yes, it is true. So it's justified. Okay, so it's proved. So hence it is terminating. As we were able to convert it in the form of 2 to the power n into 5 to the power m, where n equals to 1 and m equals to 1, hence it is terminating. As simple as that. Okay, let's move on. What is the next question? 77 divided by 210. Now 77, if you are taking 7 11 11 1. So 77 can be written as 7 into 11, and 210 if you are doing LCM, then 3 7 21 0 2 35 5 7 7 1. What we got? 2 into 3 into 5 into 7. Correct? So I have written in the increasing. It's better to write in the increasing order. Okay. Or you can write 3 into 2 into 5 into 7 also, but it's better to write in the increasing. It will look good. Okay. So 7 7 cancel out. What we got? 11 divided by 2 into 3 into 5. Okay. Now you can see over it. Compare this with 2 to the power n into 5 to the power n. So you are saying we have 2 and 5, but we have extra 3. So we have extra 3. Hence we can say that the denominator is not of the form 2 to the power n into 5 to the power n. As simple as that, because there is a factor for 3 also. Hence it is non-terminating repeating. Non-terminating repeating. Okay, very simple. If it is of the form 2 to the power n into 5 to the power, then it's terminating. If it is not of that form, then if any other factors are also there, then it will be non-terminating repeating. Okay, So next second question is, write down the decimal expansion of those rational numbers in question 1 above which have terminating decimal expansion. So we have to derive it for the decimal expansion which are terminating. So you can check from question 1 to 10. For question 1 there are 10 questions, in that only few are terminating. Which are those? I am going to write it down. So second, the first thing which is terminating is 13 divided by 3125. Okay, so we need to divide it, as simple as that. Okay, so how we will divide it? So 13 3125. Okay, so 3125. So first thing will be 0 0, we got 13, then point will come 1 0. Okay, so again this is less than 3125, so it will again go by 0, it will give me 130 only, and 1 0 will come. Okay, so again 1300 is less than 3125, so it will go by again 0, it gave me 1300 and 1 0 will come next. So now 3125, what is the nearest multiplication? So 3 into 4 is 12. I am talking about this 3. So 3125 it is, and we know 3 into 4 is 12. So 3000 into 4 is 12,000. So it will come near about 4 only. If you are going to 5, then 3 into 5 is 15. So 3000 into 5 will be 15,000. That will be more than that. So we will go for 4. Now multiply 3125 into 4. How much we will get? 5 4 ja 20, 0, 2. 2 is in our hand. 4 2 ja 8 and 2 10. 0, again 1 is in our hand. 4 1 ja 4, 1 5, and 4 3 ja 12. Okay, so 0 0, 10 minus 5 is 5, then we have 2, so 2 minus 2 is 0 0. Okay, so how much we have left with? 500. Okay, now again 1 0 will come over here, and 3125 1 ja, because if we are doing into 2, then 3 into 2 is 6000. That will be more than 5000, so it will go by 1 only. So 3125. Okay, so it will give me 10 minus 5 is 5. This will become 9. 9 minus 2 is 7. This will become 9. 9 minus 1 is 8. And this will become 4. 4 minus 3 is 1. Okay, now you put 0 over here. Then if see over here, 3 into 6 is 18. So 3000 into 6 is 18,000. So let's multiply with 6. If it is more, then it can be same, it can be more. Okay, and it can be less also. But we are checking on the exact point. 3 into 6 is 18. So let's multiply with 6. So 6 5s are 30, 3, 6 2s are 12, 3 15, 6 1s are 6 1 7, and 3 6 9. Yes, it's going exactly. Okay, so 6. So 5 6s are 30, 0. 3 is in our hand. 6 2s are 12, 3 15, 1 is in our hand, 6 1 ja 6, 1 7, and 6 3 ja 18. So you see over here we have got exact values. Okay, so it's terminated after some digits, after a point, after some digits. Okay, it got terminated. So what is the value we got? That will be the answer, 0.00416. As simple as that. Let's do which one was our next terminating thing was 17 by 8. This is very easy. 17, 8, 8 2 is 16, 1, 7 minus 6 is 1, 0. Okay, now this is less than, so point will come, 0 will come, 8 1 is 8, 2. Okay, so 2, 0 will come, 8 2 is 16, 4. Okay, 4, 40, 8 5 is 40. So we have got 17 by 8 as 2.125. Very simple, very easy. Third one. So third problem, that was, problem was 4 in the first problem, but for us it is third problem in the second, because that is terminating. So the third thing which is getting, if you want to write 4 also it's fine, but what I am telling you is this is of the second question. The third rational thing which was terminating in question 1 is 15 by 1600. Okay, so let's divide 1600 15. So first is 0, we got 15.0, again less than 1600, so it will go by 0, 150, 0 will come, again this is less than 0, so 0 will be over here, 1600 into 0 is 0, so 1500, now comes 0 again. So this will go. Now what is the nearest thing? So what is the nearest thing? So if you know the table for 16, so 16 8 ja is 128 and 16 9 ja is 144. So that is coming near about 150. Correct? I am talking about 3 digit thing. The first 3, 150, this thing. So 16 9 ja is 144. Correct? So we will go with 9, because 16 10 ja is 160. That is more than 150. So I will go with 16 9 ja. Of course 0 0 is there, but we are not considering for the multiplication, to check where I should stop. Okay, so 16 9 is 144, so we will multiply 1600 into 9. So of course 0 into 9 is 0, 0 into 9 is 0, then 6 9 ja 54, so 4 5, 5 is in our hand, 9 1 ja 9, 5 14. You see, this is what 144 I was talking about. Okay, so 0 0, 10 minus 4 is 6, this become 4, so 4 minus 4 is cut. Okay, so we have 600. Now a 0 will come. Okay, so what we will do next? 6000. So we will check for the 60 thing first. Okay, so 60 is coming. Why I took 3 digit in the first is because 15 is less than 16, right? That will not come. So we will check for the 3 digit thing. But here 2 digit is more than 16. 60 is there, right? The first 2 digit. 6 is less than 16, of course. So 1 digit is not valid. So I'm taking 2 digit. That I need to check in the 16 table. So 16 3 is 48. 16 4 is 64. So 64 is going more than 60. Okay, so what comes is 3. So 1600 into 3 is 4800. Okay, because 16 into 3 is 48, put double zero over here. So 0, 0, 10 minus 8 is 2, and finally 5 minus 4 is 1. We got 1200. Okay, now what will the next thing is put 0 over here. Okay, now again if you are checking for 1 digit, 1 is less than 16, again 12 is also less than 16. What I need to look for 120 in the 16 table. Okay, so 16 table 120, 16 8 ja was 128, 16 7 ja is 112. Okay, that is near about this, so we will go for 7. Okay, so 16 7 ja 112. So 1 1 2 double 0. So 0 0, 10 minus 2 is 8. Go. Okay, again 1 0 will come. Now 16 5 ja is 8000. Can you see this? So it got totally divided. Okay, so how much we got? 0.00. So the answer is 0.009375. So it's got terminated. Can you see this? Yes. Next. So next that got totally divided is fourth one for us, but it's the sixth problem of question 1 that got totally divided. That is 23 divided by 2 cube into 5 square. Okay. So 2 cube into 5 square. So this will be 23 divided by 2 cube is 8. 5 square is 25. So 23 divided by 200. Let's divide. So 0, 23. So point will come, 0 will come over here. So 200 1 ja 200. We got 30, and again 0. 200 1 ja 200. We got 100. Okay, again 1 0, and 200 5 ja is 1000. So we got totally divided over here. So what is the answer? 0.115. Okay, next problem, the fifth, but for question 1 it is question number 8, that is a terminating thing. So 6 by 15 it is. Okay, so 6 by 15, let's divide. 15 6 0 point, 0 will come. 15 4 ja 60. So we have got 0.4. So it's terminating. Answer very easy. Sixth one, that is terminating, is the ninth question for question 1. That is 35 by 50. Let's divide. 0 0 35. Put 0 and point over here. Okay, 57 ja 3, because 5 7 ja 35, 57 ja 350. So we got 0.7. Okay, so this is our question 9 of problem 1. Okay, so we are done with the problem 2. Now problem 3 is the following real numbers have decimal expansion as given below. Okay, so in each case decide whether they are rational or not. If they are rational and of the form p by q, what can we say about the prime factor of q? Okay, very good. So let's do the first problem. So third question, first problem. So you can see the first problem is 43 divide point 43.123 4 5 6 7 8 9, correct? So as you can see, it has terminating decimal expansion, correct? It's not repeating, there is no bar thing over here, so it's a terminating decimal expansion. Okay, so this is a terminating decimal expansion. There is no bar on the top. Hence, it is a rational number. It is a rational number of form p by q. Okay, and also q is of the form 2 to the power m into 5 to the power n. 2 to the power n into 5 to the power m. Okay, got it, right? That is the prime factor of q. That is prime factor of q will be either 2 or 5. Why I am saying this? It will be 2 to the, let's check it. How? So the same way we are going to do, we have to convert this to fraction first. 0.123456789. It's a terminating, there is no bar, hence it will be of the form, that's for sure. But how? Let's prove it. So remove point. This is for the purpose only, we don't need to do this step, but this is for your info only. So if you are removing point, 1 will come, and after point how many digits are there? 9 digits. So 90 will come, correct? So we can write this as 10 to the power 9, correct? Because there will be 9 digits. I told you, right? For removal of point, 1 come, and after removing, after point, how many digits are there? That many 0 will be there. Okay, so 1 2 3 4 5 6 7 8 9. So for point 1 comes, and after point there are 9 digits, so 90. Okay, now since there are on 1 there are 90, so this whole thing I can write it as 4 3 1 2 3 4. Now we have removed point, that's why I didn't wrote point. 5 6 7 8 9 divided by, since there are 90, that becomes 10 to the power 9. Why I wrote 10 to the power 9? You check it with the smaller one. 100, there are 2 0, right? This is 10 square. So there are 2 0, that means 10 square. Now 10, this is 10 to the power 1. 1 0, so power is 1. Now thousands is 10 cube. So 3 0 becomes the power for 10. Similarly 4 0, you will check 10 to the power 4. 5 0 means 10 to the power 5. 6 0 means 10 to the power. Similarly 9 0 means 10 to the power 9. Now as I have told you previously that this things can be written as 2 into 5 to the power 9. And I have told you already x into y to the power m equals to x to the power m into y to the power m. Okay, hence this is 2 to the power 9 into 5 to the power 9. So as you can see over here, you compare it with the form 2 to the power n into 5 to the power m. So what we are getting? N equals to 9 and m equals to 9, correct? So of course, if it is terminating, it will always be, the denominator can always be written as 2 to the power n into 5 to the power n. So you can see this, since there were no bar, so it will always, the q will be always of the form 2 to the power n into 5 to the power n. Okay, let's move on for the second one. The second one says that 0.120, okay, then 1200. You see over here 12000, then 1240 dot dot dot. Can you see the things? Here it is non-recurring. Non-recurring in the sense, see over here, here it is 120, then it is 1200, 12000. Recurring in the sense is, it should always give you, if it is 120, next will be always 120, again next 120, again next 120. If it is recurring, after a certain digit, it should again occur. I mean, the same number of digits will reoccur. Okay, the same digit will reoccur. But here you can see, first is 120, next is 1200, next is 12000, 1240, like that it is going. So there is, it's a non-recurring, correct? Neither terminating nor it is recurring. So the given decimal is neither terminating, as there is dot dot dot, that means it's not terminating, neither terminating nor it is recurring. So recurring in the sense, the same digit you are not seeing, like I have shown you over here, 0.12012. If it was like that form, then it is recurring. But since it is the same digit is not occurring again, I mean after 120, if it was 120 only, but we have 1200, then again 12000. So it's not recurring. Okay, nor it is recurring. Hence the given number is irrational. Okay, hence the given number is irrational. Okay, now third problem. So irrational number is also something. First thing is, it should not be represented in the form of q. Second thing is, it should be neither terminating nor recurring, then it will be irrational number. Now third thing is 43.123456789. Now you can see this bar. So this bar tells that whole things will reoccur again. After this 9, again if you are removing the bar, that means this will again recur. 1 2 3 4 5 6 7 8 9. Okay, then again it will be 1 2 3 4 5 6 7 8. So the whole thing, this will reoccur again and again and again. Okay, a certain digit will reoccur. So since it is non-terminating, and also it is non-terminating, it's not terminating, it's reoccurring. Okay, so the decimal expansion the decimal expansion is non-terminating recurring. Okay, so the given number is a rational number of form P by Q, but Q not in the form of opposite of that, 2 to the power n into 5 to the power n. Okay, that is, what does it mean? That is the prime factor of factors of Q will also have a factors other than 2 and 5. Okay, we have seen it already. If it is have factor other than 2 and 5, then it was non-terminating recurring. So same thing over here. Since it is non-terminating recurring, so of course it's a rational number of form P by Q, where Q is not in the form of 2 to the power m into 2 to the power n into 5 to the power n. That is, the prime factors of Q will also have factors other than 2 and 5. Okay, so here our chapter 1.4 gets over. I hope you understood everything, and if you like my video, so then please like it and subscribe my channel. There will be more topics is going to come in few days, so it will be better if you will go through it. You'll understand. If you have any problem, come back again, revise it as many times as you want, but please don't forget to like and subscribe. Okay, so we will meet again in our next chapter called polynomials. Okay, so see you till then. Thank you. Bye bye.